Thanks you all for joining today. As Hanal said, my focus is on Corticon, and been very excited to learn about MarkLogic ever since the acquisition, because there's a whole lot of parallels between the two products, and I'm going to try to elucidate and demo a few of those kind of cross-compatibility use cases for you today. What I want to start with is just kind of talking about why Corticon would be useful, because it's not always useful. There's a lot of circumstances where you don't necessarily have quite enough of a set of business rules that aren't quite complex enough, where it's not too much of a challenge necessarily to just hard code them, use the developers at your disposal, and be able to just maintain rules independently from actually having to document them. But for the same reason that a lot of customers choose MarkLogic, primarily in more regulated industries where there's a whole lot of not just regulation, but a lot of whole things that can go wrong if rules aren't followed particularly well. Corticon's very much of the same cloth. Corticon's primarily in a lot of the same markets and has a lot of the same customers, coincidentally, of MarkLogic because of its utility, not just for enabling non-developers to be the ones implementing business rules, but to enable people to be, to enable businesses to actually explain why a given decision was made in the way it was at a given point in time. MarkLogic really is a great mechanism through which to make use of all of the capabilities that Corticon provides for explainability of business rules. And so I'm going to show one particular use case all throughout here. Like MarkLogic as well, Corticon is out of the box, not specific to any particular industry, any particular use case. So I'm going to go with a fairly broad-based one that'll be mostly familiar to everyone, but suffice to say there is a whole lot of variability from the different applications that you might pursue Corticon for. So as far as the types of problems, types of questions that you might want to be able to answer that Corticon can help you with is the degree to which you are able to point to the rationale, the business logic that led to a given business decision at a point in time. So it's all great if you're able to automate things with AI and you can have some degree of determinism in terms of what you're actually getting back from one question to the next over time. That solves for one piece of the puzzle in automation, leveraging AI and the capabilities available. Doesn't really help you too much, though, when you need to explain why that decision was made in the way it was, the extent to which you can prove that it was in line with a given regulation, a particular policy that was published. You need to be able to point to, well, the decision was made based off of this business logic that was not implemented in a completely foreign application code as compared to what the actual policy text is. Corticon really allows you to never really stray away from the way that the rules themselves are originally written as rules. So by virtue of abstracting all of the logic outside of not just writing it into code, but abstracting it into the same business terminologies that the actual policies themselves are written in, drastically easier to not have to explain why a complex decision was made, but to have it kind of automatically explainable, inherent explainability via Corticon. So I'm going to talk about an auto insurance underwriting use case here, but as I mentioned, this is just for illustration's sake because I figured there's a good chance most people can figure out the basics of when and where decisions come into play in a auto insurance underwriting use case. So we're going to follow that particular use case, but I'm not going to go too deep into anything domain specific there. Now, just aside from the use case whatsoever, there are a whole lot of reasons why it's particularly useful, not just to be able to write business logic in such a way that you can explain it, but also to eliminate the degree to which you are separating out the business logic from the data. So with Corticon, we're really able to solve to a very strong extent of issues of data gravity, needing to have the right data at the right places so that the compute can actually, whatever compute system is operating upon that data, has it readily available to not just respond at some point in time in a batch, but then and there. So with Corticon, we have a whole lot of flexibility in terms of where Corticon can run, one of those options being directly within MarkLogic, so saves a ton of time in terms of just the latency of start to finish of a given decision. But before we even get to the point of actually deploying those rules and operationalizing them as either a function built directly into MarkLogic or as a web service exposed to the world, There's a lot that goes into being able to implement those rules before you even get to the point of trying to automate decisions with it. So while at the end of the day, the actual generated artifact from Corticon is application code effectively, at no point when you're creating those rules are you coding. At no point do we ask the people who are most familiar with the business rules, thereby probably the most optimal people to be implementing those rules as actual automations. We're never asking them to learn to code. We're only asking them, and likewise, we're never asking developers to learn those complex policies. So at a certain point where the policies are sufficiently complex, it makes more sense to abstract all of that business logic into a rules engine like Corticon, but then also solve for the best of both worlds in terms of the runtime performance by virtue of running those rules, what we call a decision service, when we deploy it directly where that data is stored. So effectively, Corticon.js is one side of the two deployment option coin with Corticon. Corticon.js, as the name might suggest, is the variant through which we can generate all of the complex business rules that we might implement over the course of a software development lifecycle, generate that into one self-contained JavaScript bundle, and run that wherever JavaScript runs. One place that JavaScript runs is server-side within MarkLogic, and there's a whole lot of different use cases for employing Corticon.js as a server-side function within MarkLogic. So just as this abstract example of, these are all rules. This is a very high-level summary of all of the rules that are actually implemented in this particular demo. It's not the most exciting thing to go ins and outs of an actual auto insurance policy, so I minimized it to only this gigantic block of text for a representative snapshot of some of the rules that we're able to implement in Corticon over the course of the rule modeling development experience. So there's a few ways that we might, as a business, take just this policy, might be informed by not just internal revenue requirements and risk determinations, but also to be able to make sure we're proving that we are adhering to the various state-by-state requirements for coverage minimums and what can and cannot be used for a potential risk qualifier. It goes down to things like very specific demographic aspects about a population from state to state varies in terms of whether or not you're able to consider if they're a full-time student or not. That depends at a state level. So we could write that with Java. We likely already do have a fair number of either Java or .NET developers to start to implement some of this logic. Very, very performant. Gets drastically more difficult to explain as we start to build upon our logic as we go. Or we could go with JavaScript and make it more, at least, runtime friendly by virtue of being able to run closer to the edge, not being required or not leaning upon a application server environment to run our Java application by virtue of leveraging something written in JavaScript. But what we're going to do instead here is we're going to start with implementing the rules in what's called Corticon Studio, which is effectively going to supplant every aspect of the software development lifecycle up until the point when we generate that JavaScript, which will run directly within MarkLogic, at which point it is as if there's nothing progress or Corticon specific about that JavaScript. You could have written it yourself, but you actually did not need to know any JavaScript whatsoever in order to have produced all of this complex logic, because all of the rules are going to be written as just that, as rules, not as code. So the first thing that we're going to do in order to make sure we're actually producing the data that we want, but also to solve for, again, the people who are implementing these rules are going to be people most familiar with business policies. It's not necessarily one and the same with people who know any given development language. So we're going to abstract all the different data elements into a common model, which can be informed by, say, an existing schema of documents that exists already in MarkLogic or any other data store. Or we might generate it directly from just an industry standard that you're required to adhere to. Based upon that data model, we're effectively going to assign all the different permutations of how that data might be received and under which conditions we might change data in particular ways or not when that data meets particular conditions, and do all of that in one stateless interaction. So Corticon, as I mentioned, has a lot of different deployment flavors, but at no point does Corticon ever have a database built into it. It's always effectively going to be a stateless REST API, takes data in and changes it. It'll explain a whole lot of aspects of why decision data was made in the way that it was, and you can expose a lot of that or configure it to not generate more data than you'd like. But at no point is Corticon going to be the one that you need to solve for the actual data availability. It's just going to be an endpoint that can live in an existing application architecture. So first thing again, we can just take, say, maybe that input JSON document. Directly from that JSON, we can abstract that into just this data model, which will represent all of the elements involved in the data over the course of the decision. So this is data that might be coming in just on the initial input payload on the left there. But likewise, we're going to build upon that data model, what we call a rule vocabulary. And this will encapsulate all of the data elements that might be retrieved along the way. Maybe we need to go back to MarkLogic after getting this initial input data, retrieve some additional information to make sure that they're eligible for this particular policy or not. Maybe check if a given state actually has a plan available for a type of coverage that's being applied for. And finally, all the data that's going to be produced as a result of those rules having fired or not. All of this is going to be abstracted into just this data model here, from which we're basically going to treat it as this bucket of available business terms from which we can drag and drop and define all of the different conditions under which we may or may not assign values or perform calculations based upon the values of these data and what we might pick up and produce as data from preceding aspects of the logic over the course of the decision. So what I'm showing here is a rule sheet. This is just a boiled down version of one of the individual determinations for a good student discount. So the way to look at a rule sheet in Corticon is effectively each of those columns where you see the headers up top, number 1 and number 2, those each represent a discrete business rule. They're not one or the other. They represent effectively where it's less than 25, there's no other conditions, but any number of conditions, if there were multiple ones underneath column 1, if there were multiple conditions under column 2, all conditions must be met, and then any number of actions might be assigned based off of that. So from the left-hand side, we see that rule vocabulary again. That's going to serve as kind of the parameters of the types of data and what fields we have the option of setting for particular values. And we're defining any number of conditions that might produce any number of actions. In this case, the discount category for a particular type of discount and the conditions under which we'll assign it. The other thing that we're going to do when we're implementing these rules is what's actually happening in the actions is ultimately what matters at the end of the day. That's the output of data. But again, there's a lot of scenarios for internal and external purposes for our company that we want to be able to explain why a decision was made in the way it was. So you can see just the cursor there has good student highlighted. And as a result of that, I'm in column 2. That's rule number 2. And so highlighted as well down here in the rule statement is what will be sent back if and only if that rule fires, meaning not only will I get driver.discount.category will now have a value of good student, but likewise I'll have that plain language explanation that will come through alongside that particular rule when it does fire. Now, that's nice. That's kind of the bread and butter historically with Corticon, but a lot of what we've been solving for with Corticon in recent years, particularly given the fact that there's a particular subset of business challenges where AI would be nice, but it's not exactly going to be acceptable to ever leave it out of the hands of business users. So a way to think of Corticon and its real applicability here is to think of it more as AI in the loop, not human in the loop. So AI is going to be available to help us out along the way, such as maybe I'll just paste in some of those initial rules into the AI assistant here. What happens when we run that query is the AI endpoint, it's just an open AI endpoint here. It's going to get a representation, not just of that query that's come in, but it'll also get some background context. It has the rule vocabulary that must meet that particular set of conditions, such as when we're assigning any value to driver.age, we're working with an integer data type. We can't stray from the types of values or the field names that have been constrained within that rule vocabulary. And so as part of that query, we're saying this user is asking this question, but they also happen to be working within Corticon.js Studio, and they have a rule vocabulary that looks like this. Based off that, it's able to help along the way, not just to implement things, but also to help document rules as you build them, which is very useful considering Corticon has been around for a couple decades now, so it's also quite good at maintaining backwards compatibility. That means that a lot of people who implemented rules that are out in the wild today likely aren't there anymore. So being able to improve the documentation of why a decision is made at a given point in time is drastically easier with the newer AI assistant capabilities built in out of the box with Corticon. Now, a more kind of classic thing that's always been available with Corticon, and it's always been a major differentiator, is kind of by virtue of the fact that we're looking to have Corticon be one endpoint across a broader application. That's typically how it's deployed. That means that Corticon's going to do everything possible to make sure that whenever there are potential logical issues that you're introducing over the course of the rules, it's going to try and point that out to you as soon as possible. Corticon is good at a lot of things, but it hates ambiguity. So it'll have these click of a button checks that we can run, just say, perhaps run check for completeness of the rules. It'll infer, based upon those 2 rules that have been modeled thus far, that there's a set of circumstances that you haven't said explicitly this couldn't happen. So Corticon will auto-populate all those potential conditions, and who better to answer what should happen if that set of conditions might happen, again, then not the developer, but the actual person most familiar with the business rules. So it'll populate all those different conditions, and then the rule modeler just needs to assign what should actually happen then, or optionally, they might just say, nope, that combination of things will never happen. I don't even need to solve for it. Now, that's just the click of a button checks to just kind of infer there's potential values not being solved for or overlaps within the rules, circular logic. But, of course, we have a more traditional type of regression testing, not just to check that the outputs are producing what we see, but these rule tests, as we call them, are stored and can be run against past decision services, can be run against individual rule sheets or decisions as a whole. And we can isolate where specifically particular aspects of the rules are triggering one aspect or another of the output. And you can kind of think of this as essentially like Postman, but a bit more easy to isolate where specifically a given aspect of the output is being assigned. You can see that I'm getting that rule statement back, and only one of those rule statements, despite the fact that I had multiple there, because only that particular rule has fired. And it's nice that we can have that natural language description that users are writing when they're modeling those rules, but it's also not optimal considering that we're relying on users to actually be good stewards and documenting those rules in the plain language. We can likewise not even rely upon just the rule modeler having documented each rule in plain language, but we can expose over the course of the decision every which way that the decision changes over the course of that payload being evaluated from start to finish. So just in this rule trace view, which is data that can be seen and isolated and parsed out directly within Studio, and it can likewise be incorporated into the runtime responses. This will show the sequence of events of every last thing that happened over the course of the execution of this decision service. What was the nature of that change, where specifically that change was made, the name of the rule sheet on the far right, as well as on the furthest right, the number rule within that rule sheet. And if I were to double-click on any one of those 5 sequential events, it'll take me directly to the particular rule that produced that aspect of the output, if anything doesn't look right to me as far as comparing it with what I expected that value to be. So what I showed a moment ago in that decision table type of interface, what I call the rule sheet, those get chained together into any number of nodes. And while Corticon itself is going to be generated into a stateless endpoint, so all of the data won't live beyond the actual execution of that data, of that decision service. All of the data that gets produced up top will be carried through as we go down what's called a rule flow here. This rule flow is not just a pretty picture, it likewise is demonstrating and it's operationalizing the order of events that will happen. In no circumstance will initialization and eligibility rule sheet in no circumstance will that happen after minimum coverages does. But all of the data that gets produced in the upstream rule sheets will be available in memory later on. And so we're able to operate upon and also modularize the different aspects of the data, make it easier to maintain the different elements of it, segment it out, and also potentially if we have different individuals responsible for different areas of those business rules, it's much easier to kind of maintain them independently and divide responsibilities. Now, from that rule flow, this is effectively what will get generated into that final runnable JavaScript. So everything in here that's been modeled in what we've called a rule vocabulary, a rule sheet, rule flow, and testing them against rule tests, that's all left behind because, again, what we're generating here is just JavaScript. It's vanilla JavaScript. There's nothing Corticon specific or MarkLogic specific or progress specific about what comes out. What will come out is just going to be in that top file there, a decision service bundle. That is the entirety of all of those rules, and then a few samples of how to trigger it, depending on what wrapper you might have chose from that dropdown. You might have seen that MarkLogic was the one selected, but among them might be, say, just running it on a node server or running it as a serverless function on AWS, Lambda, or Azure Functions. You'll get generated, again, just this self-contained JavaScript bundle, but in this case, we're going to have sample code for that particular platform that we targeted here to help us integrate that decision service into the platform. On the MarkLogic side, as an example of both in this example, but also just a bit of a boiling down of what that sample code is doing, in this circumstance, what we're doing is effectively loading an input document upon which a trigger will fire, and based upon that trigger, we're going to write a new document. So we're going to have an input collection in MarkLogic of policy documents, and ultimately persist all of the information into a new document about that new policy. And we can optionally, as I mentioned, configure how much of the additional helpful information about how a decision was made along the way. We can choose to configure how much of that beyond just that actual output data that we saw in the bold letters on the right-hand side of a rule test output. But what I'm going to do is incorporate information like we saw in the rule trace view as well. So we can, if you're considering a circumstance where just an individual is getting a call in a call center, somebody asking why their policy increased based upon maybe an individual on their policy had 3 particular types of car accidents in the last 5 years, we're able to much more easily isolate what specific rule caused it. And if something did go wrong, we can very quickly isolate where that problem was and remediate it that way. So this is going to enable us, just as far as the context before I jump into actually showing what we're doing, we're really making sure that all of the logic is implemented exactly as the policy is defined, while also ensuring that it's going to be operationalized exactly where the data itself is going to reside. So the performance is not really a consideration, considering we're not leaving MarkLogic whatsoever. And everything that we're doing within Corticon is going to be persisted and exposed within MarkLogic to be able to isolate every which way that we're going to operate upon that input data and assign new information based upon what's been assigned. And that last bullet point's quite important here. A very nice thing, makes my life easier as a SE for Corticon is I get to say that Corticon just kind of takes the shape of its container as far as security. Corticon, again, just the deployable is a self-contained JavaScript bundle. It'll run wherever JavaScript runs. It'll inherit any of the security that has been assigned based upon that container within which it's running. So it is very easy when we're abstracting all of the data away from the actual runtime code to be able to constrain the security and governance of that. And what we're going to see is, by virtue of exposing all of this information, and doing so in such a way that all of the input and output data is created using the same sort of terminologies that we're leveraging directly within a business policy, like an insurance policy, it's much easier to start to integrate kind of front-end querying capabilities, such as with MarkLogic Fast Track. We're going to see in a moment how we're able to leverage a lot of the capabilities in Fast Track to tell the story of kind of at a population level, how are these policies commonly being defined over the course of different states in one area of the country versus another. Maybe isolate out different paths through which policies are most commonly being gone down, what types of rules are being triggered based upon subsets of populations in order to say why or kind of do what if analyses about potential changes, as well as just to be able to answer queries about why a decision was made at a given point in time. So effectively, while all of the rule modeling, all of the definition of those rules is taking place external to this kind of data and decisioning hub framework, it's all going to be persisted in one. So we're able to have all of that available to us and start to query based off of it. So this is an example of one Fast Track widget just for a policy searcher, where I can search based upon a randomly assigned ID that I created for each of my various different policies. And we can start to incorporate and assimilate not just data about a given policy output, just the actual values themselves that were produced as a result of these rules, but likewise isolate out the particular rules and what messages might have come out as a result of the various different considerations that were being done over the course of that decision. So here we're seeing on the far right-hand side there, this latest portal is showing us the exact same view that we saw in that rule trace view of Corticon.js in the rule test. So if something went wrong, it's very quick to be able to isolate out what particular aspect, what specific entity, what kind of hierarchy that might have resided within. For example, a discount applied to one individual amongst others, one vehicle amongst 3 vehicles on a policy, where and why and how that particular rule fired, and what was the nature of that change, what it might have looked like before they were eligible, perhaps what particular rule fired such that they were now ineligible. That's just one frame that we can kind of work from just to query the actual data itself. But again, we're exposing all of this in such a way that it's all very structured, so it's quite easy to start to develop other solutions like, say, incorporate a chatbot widget, also available with MarkLogic Fast Track. If I just plug this in with one of the more rudimentary OpenAI API keys in conjunction with the chatbot widget, I can perform that same sort of query. And this will expose all of the different pieces of information that we saw, both in a more structured format, in this type more of in a more conversational format. And here we'll see a more natural language description of each and every determination that was made, isolating out and making use of all of the different fields, again, not just from the output data itself, but from the rule trace view, so understanding not just what actually resulted from the end execution of all these different rules, but also isolating out what specific rule sheet, what specific type of logic was applied, and what the rationale was based upon all of the documentation that we built into the rules as just implementing those rules. So over the course of this, we're able to start to build upon the set of data, not just from what we create, but how that data is being created, upon which types of rules it's evaluating in order to produce this outputs. And it makes it much easier not just to isolate out areas of the logic that might have produced this or that aspect of the output, but likewise to start to develop additional complementary solutions like front-end tooling, like Fast Track, in order to be able to build upon and make use of all of the good information and very transparent operations of the rules when we're running it. And so ultimately, at the end of the day, this is going to solve for one of those initial challenges that I laid out as far as the determinism that might come once we solve for all potential system prompts with a AI system. It's all well and good, but when it's, again, probably the next level, potentially, when we have at least maybe a reference to a PDF document that an LLM might have used in order to produce a decision. But that's more so human in the loop. It's hoping that humans will go check, well, that PDF actually is the one that's a bit outdated. In this case, we're really making the AI in the loop. They're going to help expedite things, expose a lot of information about how a decision was made, but ultimately, Corticon's not going to be used for every use case, as I mentioned. It's going to be used in the types of use cases where it's most pertinent and most risky to just leave that into a black box logic to actually implement all of the which ways that a policy decision, a Medicaid policy, a loan document determination, loan origination, or an insurance coverage claim might be evaluated. So this has been just one very abstract example. It's applicable across the board with a lot of different use cases. As I mentioned, Corticon is in a lot of the same markets as MarkLogic. So if you're an existing MarkLogic customer, we probably have some reference implementations of customers doing something similar as we've seen here. And it's quite easy to integrate Corticon directly into MarkLogic because we're not bringing any of the data. We're just bringing the rules that are built from that existing data schema that it's informed by. All right, so with that, I'm going to shut up for a bit, and if there's any questions, I'd be happy to answer them. But also, I'll be in the back corner there in my Demo Alley booth as well, so happy to spin up some more demos over the course of the rest of the summit. Thanks.
I do have one question. In conversations with customers around Corticon, how often does the topic come up about where business logic should reside in the architecture?
Well, where could be, I could read the word where in a few different ways. Do you mean in terms of where it's actually executed?
In the context of your opening statement about nth tier architectures.
Yeah, so I think what's unique about Corticon is that it solves for two different ways that one might answer that question. One being just for performance sake, let's not stray away from where the data is residing. That might introduce all sorts of spaghetti code that is thereby running where the data is stored. But we're actually abstracting all of the definition of the rules that's being generated into the code running where the data is in a separate environment. So it's kind of like creating something of a modular monolith. So all of the compute, all the data is residing in the same place, but it's entirely independently maintained and defined by distinct types of personas. So again, policy people for implementing the rules that are operating to actually assign values from data, but the data itself is being assimilated and produced and made available by a platform like MarkLogic or any other. So it depends on kind of the side of where the rule logic is being maintained. Ideally, that's going to be not one and the same as the answer of where it's actually being operationalized. And so that's kind of what's happening here is the rules are being defined within Corticon Studio, operationalized like any other server-side JavaScript within MarkLogic.
Okay. And not MarkLogic related, has this been implemented with clients that are also doing Lambda architectures?
Yes, definitely. Across you mean like AWS Lambda?
Or Azure's or Google's, it's the same pattern.
Yes, absolutely. So the only difference from our standpoint is the wrapper, the actual triggering code is a little bit different depending on just making it easier to run it within AWS versus Azure versus GCP versus directly within the browser. The decision services is the same. So it's quite straightforward, and we have customers kind of across both state Medicaid programs are leveraging Lambda specifically for a few child welfare applications, as well as in the private sector, in the finance space, we have a number of customers as well doing the same. So it kind of runs the gamut, and it's just one of many different paradigms through which you might deploy Corticon. So there's a lot of options that aren't necessarily mutually exclusive with one another. A lot of times it's just if a customer is trying to solve for not having to maintain the server infrastructure, they like serverless, and they're an AWS shop, they'll go that route. But we're not necessarily going to prescribe based upon the requirements that we receive that you have to do it this way versus another. There's a lot of parity across all of the different deployment mechanisms that you might choose just Corticon specific.
Thank you.
Mm-hmm. Any other questions? Cool. Well, thank you all very much for your time.